You probably remember the law of conservation of mass from your GCSEs. If we react 5 grams of A with 3 grams of B and produce C, then this must be 8 grams since there's only one product. C cannot be anything other than 8 grams, and that's precisely why chemical equations have to be balanced. Let's go through a simple example. I have 2 chlorines on the left and 1 on the right, so I should place a 2 here. Now I have 2 NAs on the right and 1 on the left, so place a 2 here, and the reaction is finally balanced. A quick rule: you're only allowed to add or change coefficients. That's the big numbers. You can't touch the small numbers. Here is another example. Start by drawing a line down the middle. Write down all the atoms on the left and the right. Count how many of each one you have. So on the left we have 3 H's, 1 S, 5 O's and 1 Na. On the right side we have 2 H's, 1 S, 5 O's and 2 NAs. We can see that the NAs are not balanced, so I need to place a 2 here. Now I've got 2 NAs, 6 O's and 4 H's. Now I need to balance the H's. The right side needs 2 more, so place a 2 here. That changes the H's to 4 and O's to 6, and the equation is finally balanced. Here is another example. This is an example of a combustion reaction. When dealing with combustion reactions, always balance the carbons first, followed by hydrogen and oxygen. Again, start by drawing a line down the middle. Write down all the atoms you've got, C, H and O. Count how many of each atom you have on each side. The right side needs 1 more carbon, so place a 2 here. Now we have 2 carbons and 5 oxygens. Now balance the hydrogens. Place the 3 here. And now we have 6 hydrogens and 7 oxygens. The left side needs 7 oxygens too. So 2 times 3.5 gives us 7 oxygens. The equation is now balanced. You are allowed to use fractions as long as it adds up to a whole number. Moving on to ionic equations. In ionic equations, only the reacting substances are shown. These reactions occur in solution. For example, nitric acid reacts with lithium hydroxide to produce lithium nitrate and water. Before proceeding to the ionic equation, ensure that the equation is balanced. This one is. Next, write down the ions formed. Now remember, only the substances dissolved in solution will react. In other words, only the aqueous substances will react. So HNO3 breaks down into H plus and NO3 minus. LiOH breaks down into Li plus and OH minus. LiNO3 breaks down into Li plus and NO3 minus. Whereas water is L, so it will not break down, and we write it down as it is. Now we need to cross out ions that appear on both sides of the equation. So that's NO3 minus and Li plus. Write down what is left over, which is H plus, OH minus, giving us water. So this is the ionic equation. Here is another equation. Balance the equation. Split the aqueous substances into ions. Notice that magnesium phosphate is a solid, so we leave it as it is. It does not break down into ions. Then you cancel out the repeating ions and write down what is left over.